The last example we're looking at is number 6 from section 2.2. So with our quadratics, we can also find a max. And so here's a word problem that's just an example. You have 120 feet of fencing. Hopefully that makes you think of perimeter. It's linear because it's feet. And it looks like it's a rectangle. So I'm going to go ahead and just draw a rectangle. Any rectangle. I'm going to label any rectangle. I've got 2 widths and 2 lengths. And so when I'm thinking about perimeter, that's just adding up all the sides. So that's W plus L plus W plus L equals that 120 feet, which is your perimeter. Now clearly you can collect like terms, so that's your 2W plus 2L. That's where your perimeter formula comes from. Now let's just say I want W to be the width. You could have picked L, but I'm just going to pick W to be the width. If I try to keep going, looking at the next sentence, it says find the dimensions of the rectangle that maximize the area. Well, let's just say we wanted to start writing a function, and we could say the area of W is going to have to be length times width. Well, if I'm going to go any further, I need to be only dealing with one variable. So can I get the length in terms of the width? Well, look above. Basically, you're just going to get L by itself. So I'm going to subtract 2W. So I have 2 lengths is the same as 120 minus 2W. I can get 1 length by dividing. So I've got a length equals 60 minus a width. So now instead of this length, I can substitute in 60 minus the width. Well, now that's also going to help me, of course, to write my function. So I have the quantity 60 minus W times W. So here's my function. I still need to find the maximum area. So I've written a function, which is great, but I need to figure out the maximum area. So if I'm going to do that, I'm going to look at standard form. So I'm going to go ahead and distribute that W. So I have 60W minus W squared. So this is now in standard form. I can determine what my A is. My A is the number and coefficient in front of that quadratic. So A is -1. And then my B is 60. Now this helps me because I can know that my A is negative, which means I'm going to have a parabola that's opening down, which then gives me a vertex that I have a max, which is what I'm trying to find, because I'm trying to find the max, which is going to be the y value of that vertex. So how am I going to find that? Well, I know that the axis of symmetry always runs through my vertex. So I'm going to use my equation x equals -b over 2a, which we've talked about earlier. This is the equation for the axis of symmetry. And now I'm just going to plug in my values. So I have x equals looks like 60 is my b, and then over 2 times -1. Well, that's going to simplify to x equals 30. Well, keep in mind that's your x value of the vertex. Well, how do I find my y value? You can plug it in. Plug it into your function. And so when I do that, I'm going to come over here. Clearly, I have x equals 30, but my x in this case is my w. So I've got, what's it look like? I've got 60 minus 30 times 30, which should give me 900. So my maximum is going to be that y value. And in this case, it's talking about area, so it's 900 feet squared.